We have a simple program here to illustrate how the loop instruction works in NetBeans. We're using the EBX register as a counter. Then we're putting 3 into ECX so that we'll loop 3 times. I'm going to set a breakpoint and then start debugging. So now we're paused at the breakpoint, and we'll step through the program and increment EBX and see that the EBX value is shown below. Then we'll see how EBX and ECX are changed as we step through the program. So I'll step here, and we can see EBX is updated to 2. Well, loop, we'll see that ECX was decremented to 2. EBX is incremented to 3. ECX is decremented to 1. EBX is incremented to 4. ECX has been decremented to 0. And when that happened, we exited the loop, as you can see here. Okay, I'm going to start debugging again. So we'll start debugging. Now I'm going to open the disassembly window. So I'll go over to debugging and disassembly. Now we can actually step through this program and in the disassembly window and get a little bit more information. We can see that at main plus 11 we have the loop instruction. So if we were to go down to our memory window and then type in main plus 11, this would put us at the location for the machine code corresponding to this loop instruction. And the 2 bytes that comprise the loop instruction are the 0xD2, which is the code itself for the loop, and the 0xFD. 0xFD is the relative offset from that position back up to the point where L1 is. So if we were to open up a Windows calculator, and I want to be in the programmer version, and I want to enter a hex number, and I want to set my size to a byte. So now I'm going to enter FD in hex, and then we can see in decimal that value is equal to -3. So that loop instruction is causing us to go back 3 positions or 3 bytes up to where the next instruction gets executed. So if we go back to our code and we add a couple of no-op instructions, we can see how that affects the relative offset associated with the loop instruction. So we'll build this very quickly. We'll start debugging again. We'll go back over to our disassembly window. And we can see now the loop instruction is at main plus 13. So if we go down to memory and enter main plus 13, we can see we have E2 again, but now the relative offset is equal to 0xFB. And if we bring our programming calculator back up again, now we'll go back into hex. So we'll just hit clear and we hit FB. We can see that now the relative offset is a -5. Okay, here we've made a modification to the program. We've put in a printf to let us see what the value is of EBX every time we go through the loop. So here's our change. This is our format for the printf. We're going to say EBX is equal to %D and print out the value as a decimal value. we still have our increment EBX. Now we push the value of EBX onto the stack. We push the message format. We call printf. And then after we return for printf, we add 8 back to the stack pointer to clean up the stack. And then we keep looping. So we should go through and have 3 printf statements. And let's see, let's build this and run it and make sure that it's working the way we think it should. So we're going to run the program. Here we go. And look, it's certainly running a lot more than 3 times, so obviously we have a problem here. So let's go back and look at our source code. We'll put the breakpoint in again at that point. So we'll go through and debug our program. So let's step through step by step, look at our registers, and try to figure out what's going on. So we have ECX is equal to 3 here. We can see that. EBX was set to 1. That looks good. And let's step through and keep our eye on those 2 registers. So everything's looking good. We called printf, and my goodness, look what happened to ECX when we call printf. What happened was ECX is a volatile register. We didn't save it before we called printf. So therefore, ECX was modified in printf, and when we come back from printf, ECX has been messed up. So we need to find a way to fix this problem. Okay, so what I've done here to solve this problem, and hopefully you anticipated what I'll be saying here, I want to save ECX, so I can save it. Pushing gives us a very convenient way to save a register. So I push ECX, then I do the printf part, and then after I get back from that, I pop ECX, and that should make the loop work correctly now. So we'll start debugging again. And we'll see if this indeed fixes the problem. So it's 1 time through, 2 times through, and then that was 3 times through, and we're out of the loop. And then you can see here at the bottom that indeed we do have the 3 printouts from EBX, and then we're getting out of the program. So we've solved the problem. So this was just done to show you to be careful. If you have a volatile register that you're doing something with in your program, you need to make sure and save it before you call a C function like printf, because it will probably be messed up in that function, and when you come back, your program may not work correctly. Okay, thanks. Bye.